The Victory, a grand sailing ship, sits peacefully in the harbor. On board, ropes, pulleys, and winches dominate, using the principles of leverage to reduce force to a level that human strength can manage. Sailors work together to operate this 3,000-ton giant, making it a marvel of its time. Then came the steel era, and ships began to evolve. At first, only the frame was replaced with steel, creating semi-ironclad ships. These sleek, swift vessels reached the peak of sailboat design in terms of speed and aesthetics, but after the era of paddle wheels, steam, and hybrid propulsion systems, the propeller, high-pressure boilers, and multi-cylinder steam engines emerged. Sailboats were on their way out. People dreamed of building bigger ships, but 3,000 tons was the limit of human-powered construction. Iron anchors, keels, and engine shafts were so massive that moving them, let alone processing them, was a challenge. The need for more powerful shipbuilding tools became urgent. In 1648, French physicist Blaise Pascal founded hydrostatics and proposed the principle of the hydraulic press. He conducted the famous barrel experiment, where just a few cups of water in a thin tube could crack a wooden barrel. But poor sealing technology kept hydraulic power, a sealed giant, locked away. Fast forward to 1775, when arms manufacturer John Wilkinson used a boring machine to create precise cylinders, solving the problem of piston leakage. This breakthrough helped perfect the steam engine and marked the beginning of hydraulic technology. Inventor Joseph Bramah, 12 years younger than Watt, made significant contributions. He worked on everything from toilets to printing presses and ran the largest lock factory of his time. In 1795, alongside his brilliant apprentice Henry Maudslay, later known as the father of machine tools, Bramah improved cylinder designs, using rings to enhance sealing and creating the first practical hydraulic press. Initially used for oil extraction, these presses grew larger and became essential for shipbuilding. Hundreds of tons of steel could now be shaped like dough, making hydraulic presses a cornerstone of the aviation, shipbuilding, and machinery industries. In 1961, China built its first 10,000-ton hydraulic press, a monumental achievement. By 2006, China had built the world's largest 15,000-ton hydraulic press, setting a new record. Before hydraulic presses became huge, large forgings were made by hammering. After Maudslay's death, his apprentice James Naismith took the lead. In 1862, faced with the challenge of forging a nearly 1-meter diameter engine shaft for the SS Great Britain, he invented the steam hammer. This monster could deliver earth-shaking blows, and soon steam hammers became common until large hydraulic presses replaced them. Meanwhile, as Newcastle's docks bustled with coal, cotton, and tobacco being loaded by hand, William Armstrong invented the first hydraulic crane in 1845. Using high-pressure water piped from a nearby reservoir, twisting a valve could drive a piston to lift heavy cargo, a black magic invention that revolutionized shipbuilding. By the late 19th century, as material calculations, riveting techniques, and corrosion-resistant iron improved, the foundations were laid for building massive ships. This marked the first revolution in shipbuilding, ushering in the era of steel giants and naval supremacy. But riveting had its flaws. In 1912, when the Titanic hit an iceberg and sank, it was revealed that weak rivets contributed to the disaster. Post-war, nations began to limit naval tonnage, and rivets, being heavy, were the first to go. Welding technology took off, thanks to the discovery of the electric arc and acetylene gas, which allowed steel to be melted or cut with ease. By World War II, modular construction and welding replaced traditional methods, drastically improving efficiency and cost-effectiveness. Ships were built in sections, assembled quickly, and launched in record time, 42 days per ship, sometimes just 4 days. This innovation ensured that more ships could be built faster than they could be lost, playing a crucial role in the war effort. The third revolution in shipbuilding was led by modular construction and automation, transforming shipyards from labor-intensive hubs to equipment-driven factories. Today, the shipbuilding industry thrives globally, with Asia at the forefront. Advances in technology and efficiency continue to drive the industry forward, ensuring that shipbuilding remains a cornerstone of global trade and innovation.